I want to welcome Dubossarsky to Montreal virtually. He's a lecturer in the School of Electronic Engineering and Computer Science at Queen Mary University of London. And he's affiliated lecturer in the Language Technology Lab at Cambridge, University of Cambridge. His research focuses on NLP and AI with a natural language programming and AI, with a special interest in the intersection of linguistics, cognition, and neuroscience, integrating advanced mathematical and computational methods across disciplines. And with that, I hand it to you, Hein.
Hello, everybody in Montreal and over the world. Thank you for the invitation and the opportunity to present my view on language change and how it can contribute to the task at hand, which is understanding LLM understanding. I'd like to add to the kind of introduction that Stephen has just given, the fact that I have my roots in the humanities and arts, among others. So I come from a semi-linguistic background, and basically through the study of film and film theory, I had the first encounter with linguistic, which is not generative linguistic, of course, but more traditional structuralist linguistic, which kind of fit to what I think LLMs are doing nowadays, and also might be of relevance for the last few slides of this talk. So I've changed the title of this talk just a bit. Who's afraid of language change, and how is language change relevant for understanding LLM understanding? Okay, so meaning of word change over time. For example, if we take the word adjective awesome in English, 17th century, it was used to describe tyrants like Ivan the Terrible in Russia, and in recent years, or since then, it has undergone a process of language change in which the original negative connotation of that word have become something more positive, and Barack Obama was considered among his supporters, of course, as an awesome leader. There are, of course, plenty of examples. Another example would be lexical replacement that does not entail the change of meaning of a particular word, but how we refer to a particular reference in the word. For example, the city of St. Petersburg in Russia, and then Soviet Union, and then Russia again, that has changed its meaning to Petrograd and Leningrad, and then again completed a circle, and now it's called again St. Petersburg. Now, meaning change, which I would refer to as semantic change during this talk, is rather ubiquitous among the world languages, at least the word that has historical documentations, and it has been attested. So it has been, I would say, a focus of massive historical linguistic studies in philology and historical linguistics over the past 200 years, mainly among French, English, and German scholars, Brielle, and Reisig, and so on and so forth. But we can even find attestations as to that phenomenon as old as Aristotle. And if you are in the field, you can see that language change did happen even in ancient Egyptian, in biblical Hebrew, in Aramaic, in Farsi, clearly in ancient Greek to modern Greek, Latin to Vulgar Latin to the entire Romanesque languages, and so on and so forth. So this is not only ubiquitous, but as far as we can assume, is also a universal and a key linguistic feature among the world languages. Now, yeah, okay. Now, why change or semantic change? And I put in parentheses also language variation matters. So this is basically the outline of this presentation, of this talk. It matters if you're a linguist, and I think the background that I just gave gives you an indication of how important it is for historical linguistics. It matters also if you work on AI, as I will touch very, very briefly. But it also matters if you're an historian, sociologist, or just interested in any societal and cultural changes that certain societies underwent over the times. A lot of my research is done under the umbrella of the Changes Key International program. However, the kind of message I try to convey today is entirely personal, okay? And please do not take it against the wonderful members of the Changes Key program. So just to echo what I think has been mentioned so far in different kind of presentations, we can learn some lessons from the history of science. So basically, what is a good model? I think it was mentioned again, the model of the solar system, which used to be geocentric, and since the Copernican revolution is become heliocentric. So the geocentric model was not a bad one, okay? It provided very accurate prediction of the exact position of celestial bodies, and it's still accurate today if you consider only the planets in our solar system. In fact, even after Copernicus, the prediction of the heliocentric model was very, very bad, okay, for just for about 100 years, until Kepler came and said, you know, Copernicus, no, he died back then, of course, it's not entirely circular, it's elliptoid. So if we change that, we can improve the accuracy. It was even theoretically wrong because it lacked a theory. Only 180 years later, with the Newtonian, I would say, mechanics, then we had a good model, a good theoretical model that can explain why certain objects circle around the sun and so on and so forth. However, of course, this heliocentric model was the one that enabled scientific advancement and not the geocentric model. One of these was the prediction that according to the position of the planets in the sky, there should be another planet, which was then unknown. I think it was Uranus, and Uranus was actually discovered 100 or 200 years later after this prediction was made, because this model provides predictions that geocentric models do not provide us, okay? Now, the question, of course, is relevant in our domain. Is our LLMs good models even if they do not exhibit key linguistic phenomena like that of language change in general and semantic change in particular, which is my topic for that talk. So a bit of a background and motivation. How do we model change? Okay, and try to abstract away what basically we're doing with the state-of-the-art models. And we model change as the same way as we model meaning. And by that count, we simply look at the co-occurrence statistics of word in context across different domains, different topics, different genres, and so on and so forth. And this very clear but very rare example, okay, shows us the simple co-occurrence count of the word apple with which word it appears in its context. You can see here on the different rows. So computers, big, pie, tree, atom, and so on and so forth. And you can clearly see here on yellow the fruit sense of the word apple, predominant the co-occurrence table up until the 70s or 80s. Words like big apple, pie, apple tree, Adam, trees, juice, and so on and so forth. By the way, Macintosh is a specific type of apple, which is a bit odd that it didn't appear with the word apple before that. And only after Steve Jobs and Apple as a company became a thing in our life, we can see the word co-occurring with the word computer, Jobs, Steve Jobs, or let's find some the decent place to work at, Macintosh, IBM, and so on and so forth. This is a real example, okay, taken from the English corpora. You can try and play it with yourself. Clearly, not all of the words show such a distinct change in co-occurrence patterns. But this is quite naive, but still works. And this is basically the basis of how we model meaning. I think we all know that. This is basically what large language models do, even if they're finding on different tasks. And this is also how we model change. So how do we treat change computationally? So taking this kind of a naive demonstration, same way that we model meaning of words. So we all know this. I hope we will know that if we kind of extract a vector, whatever static embedding, large language model create a vector for the word automobile, for the word car, for the word horse. We can evaluate how it's similar to words are per particular domain, per particular text, per particular corpora, per particular model and time period, according to the cosine distance, which is the angle between these two vectors here, just for the sake of illustration, portraying as two-dimensional projection. So automobile and car are almost synonyms, so they have much smaller angle than relative to horse, which is also an animal, but used to be a means of transportation. If we take it to the domain of historical language, then we simply replace these different words with the same word coming from different time periods. So extracting the word broadcast from a corpus in 1880 would most likely refer to the original meaning, the agricultural meaning of the word broadcast, which is a technique of spreading seeds in the field, okay? This did not change much from 1818 to 1920, but in the second, or I would say since the 1920s and 30s, the new meaning, which is much more prevalent nowadays of the word broadcast, which is related to telecommunication and media, emerges, and we will be able to detect such change as a much larger, wider angle in the cosine distance. So we define computational semantic change as change to word representation between two time points. And then that would be word relative to itself, usually using the cosine distance. Of course, there are other methods looking at the nearest neighbors pattern and so on and so forth, but basically it is very, very similar, and we can use it even for very, I would say, old-fashioned count-based models from either that or PPMI or static word embedding or contextual embeddings or large language models, or we can even try to look at the probability, but this is the essence. Okay, we basically compare the word relative to itself, or compare the words nearest neighbor relative to itself. In the case of the word broadcast, that again changed the meaning from an agricultural sense to a media sense, okay, we will create a vector representation of that word, compare the embedding space of that time period, T0, we will see that broadcast is much closer to words like seed and crop and further away from words like news and reporter. And we will actually see, and this is actually what we see when we do the analysis, that the word traversed a significant distance in this embedding space. Okay, now it is much more closer to words like news and reporter. If we can measure this distance, we basically have a measure of how much a word changed between these two time points. And again, let's have the same naive co-occurrence kind of approach. This is the word broadcast, in yellow, the original co-occurrence pattern. And you can clearly see that the change started at around 1920s and 1930s. Okay, so if we compute a vector representation only based on historical corpora at 1880 or 1890 or even 1910, we restrict our corpus. Let's say we do not use large language model, or we do train large language model, but incrementally over the time, okay, and then have a snapshot that stops at around 1910 or 1920, and then create a vector representation of the word broadcast. Then we have an accurate representation referring only to the agriculture sense and not to the new emerging sense related to media. And then if we compare the two, we have a measure again of semantic change. So I just gave a quick kind of 101 on how we compute a semantic change computationally. And of course, if we do it for one word, we can do it for the entire word in the corpus. We can decide on which time beans we would like to focus. We can we can analyze, like, for example, if we have Twitter data, or X, formerly known as Twitter, we have much finer resolution of the meaning than if we're actually dealing with historical language like Old English or Middle English and so on, which are limited in the time resolution. So let's have another look, and by that I'll conclude the background and motivation of how measuring semantic change looks like in the wild. This is quite an old slide, so please forgive the, I would say, not completely up-to-date graphics conventions. We will see here how the word cell changes its meaning over the course of the 20th century with 10-year increments, okay? So for every decade, we can compute how close the word cell was to this 25 or 30 anchor words, okay? The closer a word is to the anchor word, it means that the most similar the meaning of that word is to word like, so cell start with being quite close to the word cottage, cabin, tent, and so on. Again, referring to the physical confinement meaning of that word, but also not very far from word like prison and dungeon and garret and so on. And on the left side on the table, we can actually measure the trajectory and the distance that the word traversed between every decadal beats. So for the most part of the 20th century, the word hovers around that. We can even treat that as noise, okay? I hope, I'm sure, but I also hope that we can all guess what happened to that word, to the word cell in the last decade of the 20th century. Of course, the emergence of the mobile telephony and the word of transverse the further distance, okay? Again, showing that the word has changed its meaning quite significantly. And those of you who actually the very sharp observers, you may ask, where are the relevant words that relate word cell to the biological meaning? I would say a very good question, and bear with me, and I'll touch upon that in the next few slides. So, why change and also variation? Yeah. There was a great question? No, okay.
Not that I can see.
Okay. So I just heard the noise. Okay. So why change and also variation matters? Let's start and just quickly conclude why it matters if you work on AI. Because the current modus operandi, okay, of how we work with large language model is basically we go to the repository, treat it as a library, and try to find which model best serve our particular task at hand. This is also true for academia and research in academia, but definitely true for industry and such tasks. It works well if, and I would like to add, if and only if the domain is very similar to the training task. If we're talking about sentiment analysis, then of course, if we have a model that was trained on reviews of restaurant, the task also should be relevant to the reviews of restaurant and not necessarily to movies. Okay, if we move further away, then okay, the model performance deteriorates. And of course, optionally and much preferred, if we can fine-tune this model on a suitable data set that is much closer again to the target task that we have in front of us. So this is of course problematic if language changes, if the meaning of word changes, but also if there are grammaticalization changes, if there are I would say style changes and so on and so forth, is also problematic for cross-lingual setting, but I'm not going to touch on that today at all. So again, I don't want to be, it sounds like the criticism about how most NLP research is being done today, and I think it also has many advantages. We all start with a relatively small, even if Hugging Face is huge, but we all start with a relatively small set of models, unlike a couple of years ago, which every group used to train their own models on different hyperparameters, different setup on different models, and what have you. So we have a good basis of comparison. It also saves a lot of time and money and energy. So it's not necessarily bad, okay? Perhaps it's not good for languages, or it's not good for science under a certain condition, which we will see next, okay? So this is a very good work done by Rabal El-Khalifa from Queen Mary University. Basically, she compared a bunch of models, either static embeddings or contextual embeddings, and not really LLMs, but I think we tested it all, and of course, LLMs showed similar performance drops. So she basically computed the temporal gap in years. So on the x-axis, you can see how many years have passed since the corpus that was used for training a model, okay? Then when the data set or the task of evaluation was curated. 0 means that the model was trained and tested on data, on text of the same year. And if you would go back in the past or to the future, the gap increases. So certain tasks, okay, we can perhaps focus on the leftmost panel. So in terms of gender inequality and stance detection, we can see that the model performance dropped significantly, and it's relatively symmetrical almost. So it means that if we train a model today and then test it 2 or 3 or 4 years into the future, the model performance could drop significantly. And it's not ubiquitous for all the models. Sentiment analysis show much less of an impact. Reviews of rating show moderate impact, but this is something we must be aware of. And the conclusion, I think, is this: that some models, and perhaps on specific tasks, do not age well. And Rabab al-Khalifa also started with colleagues a new, I would say, workshop and seminar task for evaluating, I would say, how bad model age with time and so on. And this, of course, has significant costs on deployment, on training, and also on understanding of how can we trust the responses of large language models. So that was a very brief on white matters if you work on AI. I would also like to focus on, by the way, I'm happy to take, I know we have time for questions later. So, so I would like to kind of put the spotlight on white matters if you're an historian, sociologist, or interested in societal changes, because I think, okay, this is kind of touches a bit on the digital humanities, but I think it has a much broader implications. So, referring to the cell that was missing the biological meaning of, in the example I showed before, the meaning of a word that is represented as a vector or in our model is very much tied to the text, okay? If we treat our models as a black box, because it does, but really it doesn't matter, and we restrict what kind of domain, what kind of corpus do we use to train it, then obviously if we train it only on the text from the British Parliament, then the meaning of words will be very different than if we train it on Twitter. Oh, sorry, X formerly knows Twitter. If we train it on the corpus of soap operas, by the way, there exist a corpus like that, or only on academic papers. Just to give you an example, word like resolution and act will have very different meaning if corpus is only trained on British Parliament. Act is a type of bill, of a law that passed in the Parliament, and not really, act as a theater play and so on and so forth. If we think of the word like cell, space, and object, the meaning will differ significantly if we train only on academic papers, right? Cell will refer more to maybe to mobile telephony kind of technical terms, but also, of course, to biological cell. The fact that in the example before that I showed you the word cell, it was lacking the biological sense is because I trained it only on fiction in English, which does not really represent how important cell is in biology and so on and so forth. Space and object, of course, will completely change their meaning if basically the model only reads physical reviews and so on and so forth. And of course, words like husband and love will have a significant different meaning if the model is trained basically on soap opera. And this is, I cannot see you, but this is usually the point where the crowd laughs a bit because, okay, you can imagine that soap opera have like distinct senses of the word like husband, love, betrayal, romance, and so on and so forth. You can also add like, imagine how it would significantly differ if we're training a model on L2 corpus or corpus that is associated with people with mental health and so on and so forth. So meaning is very, very tied to the text. And we can also conceive that as a sort of language variation, not in time, but in different domains. And if models are not able, or if we're unaware of how influential it has, how influential it is on the meaning of words, we are not in the best position. I would like to argue now, okay, that it is not necessarily good or bad. Okay, so probably you know this one. This example that show the gender bias in LLM. So here you can play it with yourself. We projected words in feminine and masculine form. For example, hair and heiress, king and queen, prince and princess, and so on and so forth, on 2 axes. On the x-axis, we have, I would say, the gender x, okay? The further a word is, what is represented here is a dot, of course. The further a word is sorry, the closer the word is to the right, okay, it's masculine. The closer the word is to the left, it's more feminine. And on the y-axis, the level of royalty. The higher the word is the more royal. The lower, the more ordinary people. So, of course, I'm going to ignore the y-axis at the moment here, but I'm just would like to show that basically models capture a very strong gender bias, even if the models are not explicitly, they should not know that hair is masculine and Harris is feminine and King and so on and so forth. They can clearly set it on one side of the scalar of the axis here, and this is something that traditionally we consider as bad. We call it bias, big bold red letters. I would like to argue that bias is neither good or bad. Of course, it contains a whole host of large language model can infer a lot about our gender, demographic, according to our linguistic preferences, and so on and so forth. And this is toxic. Okay, it's toxic if this kind of information infiltrates our models that, in the end, prove semi-automatically or completely automatically if to approve or our bank loan or not, and how much should our university essay should be ranked and so on. Okay, and I'm trying to deal with this kind of issue in the democratizing AI project I lead, but it's not the case here. But on the other side, the good side, it can provide us with, I would say, a mirror, okay, to understand our society and also how it changes over time, or different societies, because we have like different languages. So it actually opens up the door to study how law changes over time, how ethics, history, sociology also change over time, and what are the cultural trends, okay? And also we can study marginalized community whose speech and speech act differ sometimes significantly and sometimes not that significantly from the standard language, including dialects and so on and so forth. So it's not necessarily good and bad. I just like to give one example how semantic change can cause bias, okay? The case of reclaimed language. So reclaimed language is the case where marginalized community starts to use the vocabulary of the oppressor, okay, and try to reclaim it to actually empower them, okay? So in this work, which was recently published, we basically tried to test how hate speech models, like state-of-the-art hate speech models, are being able to handle reclaimed languages. You can see here in light green, standard model, state-of-the-art, does a very good job in identifying hate speech, okay? But poor job in identifying reclaimed language. And again, what do I mean by reclaimed language? Reclaimed language can be perceived as part of hate speech, okay? If we are not trained, even if specifically if we're not trained in that particular jargon of the marginalized community. And what we try to do here is to tease apart the reclaim usages, reclaim meaning of hate speech, and distinguish between pure hate speech and reclaim model. And we took, as an example, as a marginalized community, the case of trans community and how they use certain vocabulary words to empower themselves. Not surprisingly, basically, the state-of-the-art model of hate speech detection failed to understand the new meaning, and we had to figure out some ways to...
Could I ask you to give a little bit more detailed account of what reclaimed language is? What I understand from it so far is that if the marginalized group starts to use it in a positive way, and those who are sympathetic to it use it in a positive way, you would call that reclaimed?
Yes.
Is there a criterion? I mean, you have a bunch of people say a bunch of words. How do you know whether they're saying it in a reclaimed sense or an original sense?
Okay, very good point. So I will let's consider the word sissy. Okay, I know it's I try to be very precise here because it's could be a minefield. So let's consider the word sissy. In certain contexts, it is used in a derogatory meaning, but usually when used among trans community, it is being considered as actually empowering. Okay, it's similar like the N word in African American communities.
That part I think we all understand. What
Okay.
I'm wondering is how do you, when you get an occurrence of it, how do you infer whether it's being reclaimed or original?
Okay, fair enough. So I would say the best way is to have a high quality annotation with members of that community. In this particular case, the student Esther Shishko had a really nice hack. She basically used the transcript of the word of the TV series RuPaul Drag Race, assuming that all, because it was broadcast in TV, assuming that there is no cases of true hate speech, and all the cases in which state-of-the-art model of hate speech detected words as being hate speech are actually false positives and should be classified as reclaimed. So it was a hack, but I think a good hack. I'm not sure there are good ways to actually handle it automatically in all cases without involving the actual member of the speech community. Okay, and this is a general criticism on those who train and develop large language models, that they need to invest significantly in terms of money and effort to reach out to different communities, not only marginalized, but also elderly and younger and immigrants and so on and so forth, to have a better account of what certain words mean for them. This is just, considering a reclaimed language, not necessarily every other aspect.
Penny
So,
C has asked two questions that are relevant here. The first one she asked a little while ago, which was just are sort of labeled populations publicly available. The corpus of labeled populations, where you get a corpus and you know what is the special demography that it refers to, are those publicly available? And now she's asking, is there a specific list of linguistic features you use to identify the difference between hate speech and reclaimed language?
so the answers are most of the time no for the first and for the first one, and actually not really for the second one. This is I would say a blind spot of NLP in general, and I think it's blind spot again because it cannot be automated in the way that we used to automate most of the tasks. Okay, we actually need to collect data from that community annotated manually if we actually want to have a high quality data set, and we need to keep it updated. We should perhaps treat that cases of reclaimed language to give them the same treatment we give to low resource languages, understanding there are no shortcuts. If you want to support a low resource language, which are not really low resource, but are only low resource from the eyes of the large language model, because they have no like billions of tokens corpora. So we need to collect the corpora, annotate it, classify it to certain genres, domain, and so on and so forth, and provide as much metadata and labels that are relevant, okay, in order to train our model. There are no shortcuts in that. Again, particularly here, the student had a really brilliant shortcut, banking on the fact that anything that was broadcast in national TV or cable TV could not be true hate speech and then must be false positive. Okay. I'm happy that it attracted your attention. If you can read more or reach out in the paper, which was just published last month. Okay, so but that was how we solve the fact that language change causes bias, and actually the positive part of languages of language change, as I mentioned, is the fact that it can open a door to study a host of cultural, historical phenomena in our society. Here, the work of Simon Henschen from 5 years ago basically tries to understand how the concept of nation change over time. Okay, providers like first it was related mostly to economy, and then gradually moved to politics and culture and so on and so forth. Another paper, again, quite old, but still quite relevant, allows us basically to go back and figure out what was the meaning associated with certain topics. For specifically, Fermat used topic modeling back in 2016. It was a much more popular approach. So how was the concept of transport being, what was the meaning in historical corpora, or how did the energy was perceived through time? In the 18th century was more related to water, and then of course with the advance of technology became more relevant to steam, and then I think yes, in the mid 20th century the nuclear energy came to be. And again, this is a litmus paper of our society and how it changes and how we define power or energy, and so on and so forth. And again, a good opportunity to test this kind of trend historically. We have some examples of financial concept, which I'm going to skip because I'm thinking have in mind that I have quite a few slides. But basically, we can use the same very, I would say, robust types of analysis I showed before on the gender bias with king and queen, hair and heiress, and so on and so forth, to almost any cultural concept. Okay, so here, really neat work of Kozlowski on the Geometry of Culture, also very good title, highly recommend read. We can see that he tried to project certain types of adjective related to affluency. Okay, and so on the right side, rich, richer, affluence, expensive, wealthy. On the left side, poor, poverty, and so on. Of course, this is no news. But when Kozlowski also added, let's say, certain sports name, okay? So basically, he created the axis on the right side, sports types that are related to the rich, and on the left side, sports types that are related to the poor. So we see here camping and boxing and bowling and hockey, okay? And on the other side, golf and tennis and so on and so forth. And when I give that in the UK, I think it's very. Everybody asks me about why camping is considered to be quite poor. I think it's again very cultural.
Say that again. You have Chaim, I have to tell you, feedback. You have a tendency to scramble the words at the end of every sentence. So you have to slow down at the end of your sentences. What did you say just now about why is what a rich what?
Okay, so what Kozlowski did is created an axis of affluency, and then he projected certain sports names or according to how close they are to richness or poverty, and what you can see here in the example. And certain sports type, or I would say recreational sports like camping and boxing and so on, are much closer attached to the poor than the opposite, like golf, tennis, volleyball, and so on and so forth. And of course, this is not restricted only to sports type. We can include also the axis of masculine and feminine in it, and we can compare different cultures in different countries. As far as I know, Brits do not consider camping, as in the example here, is something related to the poor, but actually something more related to the rich. Again, it's worth noticing that Kozlowski did his analysis, as far as I know, on American English and not British, and we can, of course, change the axis. And not only that, we can add a temporal dimension to that, basically trying to figure out what was the trajectory in terms of social status of jazz or opera that became like more posh, which we I think all know became much more considered like much more posh, and opera became a bit more popular over the years, and so on and so forth. And again, we can study any or almost any cultural concept, either looking only at variation across different languages and cultures, or adding the time dimension. So I hope I was able to cover why change matters in AI, and if you're a historian, sociologist, and interested in societal changes. Now let's move why it matters if you're a linguist. Again, getting back to the root of the phenomenon and the fact it's almost universal as far as we know through the word languages. So how we did it before? So this is how basically philologists and historical linguists worked before, by close reading, okay? They extract the meaning of words from the text, recorded it, and then look at a text from a different time period or different language or different genres. And how do we do it now? Of course, I'm sorry for the pyrotechnics in the slide. We do it like large scale with computers. This allows us several things that almost nobody could have done manually before. So, for example, quite old work of mine, and we could test directly linguistic theories on a much larger scale. So in this case, we had an hypothesis and asked, can a category membership explain semantic change? And we based our work on the work of cognitive historical linguistics, which is also part of our Changes Key program I mentioned before. So Dirk, I think it was in his PhD, examined and analyzed two verbs in Dutch and compare them between the 16th and 19th century, really actually going to the historical corpora and mapping and documenting them in text. Mind you, it was in the late 80s, early 90s, and had a conceptual map of which senses is related to each verb. And he came with the conclusion that the more prototypical meaning of a word are better protected through against a semantic change through time. Basically, he was building on the cognitive category theory of Eleanor Roche, that according to her, we encode the meaning of words and grouping them according to categories. And the canonical example is the category of birds, and which at least in North America, robin is considered one of the most prototypical bird-like, okay? And the further you go to the outer circles, you get to owl, peacock, and then when you still have like penguin and ostrich, which are so non-prototypical, they do not even share the key features of a bird, which is to fly. So that was the idea of the Hertz. And in our analysis, we basically try to see whether or not this rule holds for the entire lexicon. So we did the same spiel as before. We had like a historical corpus. We divided to certain time bins. Okay, for each time bin, we extracted the word meaning, and we did it for the entire lexicon. And then we clustered the words, and this cluster, for example, capture manners of motion. So you can see here that verbs like walk, ride, and swim are more closely related to the centroid of the cluster, meaning they're more prototypical than verbs like wander, travel, and even stroll. So we had the opportunity to measure the degree of prototypicality as a function of how close a word is to the centroid, and we're able to find that the more distance a word is from the centroid, the more likely it is to change, basically affirming the Hertz hypothesis from 30 or 40 years ago, and we call it the law of prototypicality. Okay, so this is just one example of how language change can enable us to do research in linguistics. We also had
question on that one. I have a question on that one.
Of course.
Your measure of distance, as you described it in the very beginning, was a measure of co-occurrence and a sort of a cosine similarity measure, right?
Exactly. Yeah.
How does co-occurrence frequency relate to frequency?
It's a very good question, and so good that we actually had a paper on it. If time permits, I will describe it in 3 or 4 minutes.
Okay.
Thank you. So this is just one example of how we can use large language models. Basically, that particular paper was not a large language model, simply a static embedding, but it should apply nevertheless to what we're doing now. So with this sort of large scale approach, we can also do exploratory research. Okay, and in this case, we ask, do certain word classes change more than other over time? So basically, we had the same spiel. We had analyzed how much each word in the lexicon changed over time, and we grouped it, or we grouped together words with similar part of speech category. And we have found that over time here, verbs marked in blue change more than nouns and adjectives. So basically, for each time being, we sampled 2,000 verbs, 2,000 nouns, 2,000 adjectives, and computed the average amount of change throughout the 20th century. And we see that throughout the decades, verbs change more than nouns. Now, we immediately called it word class effect, but to be honest, we were very surprised by the facts, and we had no theoretical basis to support our finding, or even to explain it, or even to be sure that we are not just, hallucinating. And this is because this sort of analysis was never done before, and actually could not have been made before, because it does require that all of this work should have been done manually. So collecting and measuring semantic change with regardless any model that one has in mind, but actually going to the text and find out how much a word changes and so on and so forth. And this word is impossible to do manually. Okay, so we were very lucky to actually find some previous work in psycholinguistics by Gentner, who is a Canadian psycholinguist who did really remarkable and interesting research 40 years ago. And she coined or reported the verb mutability effect. Gentner's studies were psycholinguistics experiment in the lab, like online synchronous readability exams. What she found is that when participants are giving a sentence with a semantic mismatch, like the following one, the lizard worship the sun, participants are more likely, in order to force understanding, more likely to expand the meaning of the verb than to expand the meaning of the nouns or adjectives. Okay, and we hypothesize, and this is basically what she wrote, verbs are more prone to alter the meaning when conflict of meaning occurs, like in the sentence, the lizard worship the sun. And we assume that if this is a synchronic effect, but it is robust, and she also reported it in 6 or 5 or 6 languages, except Japanese, which is just a side note here. But we hypothesize that if this synchronic effect is so robust, so over time it accumulates to have a diachronic and historical fingerprint in the fact that the verbs will change more than nouns. Of course, this was our post-hoc hypothesis, but we were very, very happy to see that only 2 years ago, Gentner, with a student of her or colleague, have picked up on our own research, okay, and revisit her prior studies, which is, again, of course we took it as as a compliment, but also as how new tools can steer research, okay, and allow research to revisit their own finding 40 years later. And of course, the story continues. There are other groups trying to either refute or support our findings, or say that verbs do not change more than nouns, but it depends on the circumstances and so on and so forth. Okay. This is again how language change can support research. So I did promise you to touch about frequency. So it is a tradition in historical linguistics, or maybe in science at all, to find some laws that could explain in a more robust and global manner certain phenomena. So there's no surprise that the race for law of semantic change started almost immediately after the first work that tried to do it computationally, with our law of protypicality perhaps was the first, but nevertheless, the following year, William Hamilton, which I think is in McGill now, published a paper on 2 laws of semantic change, the law of innovation, saying that the more polysemous the word is, like in this toy example, the word bank, the more likely it is to change than word that has less meaning, like the word wine here, that according to this toy example is quite monosemous, has only one meaning. And also the law of conformity that stated that the more frequent the word is, the less likely it is to change. Okay, and we actually revisited these two laws of change, and we pointed out that there could be a confound involved here. And you're right, Stephen, confound was frequency. So basically, we replicated what Hamilton did, and basically he kind of divided historical corpus into decadal beans, feeding into his model, and then created the results. What we did here is adding a control corpus, where we took an historical corpus and basically.
Chaim, I just want to remind you that you are lapsing into tachylalia at the end of your sentences again. It was wonderful for 10 minutes. So slow down.
All the habits are perhaps difficult to.
Yeah. So you need reminders, just like ChatGPT. Go ahead.
Well, that's a compliment. I'll find hard to resist. Okay, so basically I had an idea of a control condition where we were able to show that the same effect that Hamilton reported before was actually observed in a corpus which has no historical depth. Okay, it was completely synchronous, and basically we were able to. So this is on dark gray are the original results by Hamilton, showing that the size of the effect of frequency of polysemy and also our prototypicality effect, and it is largely replicated almost completely using the control corpus. Unfortunately, also our prototypicality effect from before about manners of motion and so on and so forth. So yes, so we need to be careful with the outputs of large language models because they contain a lot of confounds, statistical confounds, which we rarely understand. We know that from all the branches of NLP, biases and confounds that are related to word length and sentence length and so on and so forth. And basically, I'm going to skip the mathematics here. Basically, we found that the law of prototypicality and law of conformity are largely diminished, and the law of innovation that's related to polysemy is completely abolished here. Okay, and you're right, Stephen. Frequency has a key role in it. It is a major confound here. I'm happy to elaborate in the question and answering stage if you're interested. Okay, but the surge of laws continues because this was, I would say, the historical background of this field, and historical linguistics emerged almost together with the laws of sound change, the Grimm law of sound change, and so on and so forth. And it's not surprising that people are searching for laws of semantic change. So it is still a question of debate whether or not frequency has a role in language change or not. I don't have the time to get into that. It could be that that it does play a role, but far less important as previously mentioned by Hamilton. But we still need to be aware that the fact that large language models are deeply confounded by the frequency of the word. Okay, so the return of law of conformity that is actually states that frequency is very relevant to a semantic change. So perhaps this is the return of it, but I think the more important part is the good research is one that steers a good discussion. People are either confirming or being able to refute previous laws and finding. This is how we know good research progresses. So, but again, I think this is the part where I provide my personal opinion. I think we kind of dodge the main questions and the main problems in historical linguistics using computational tools, because basically we do what we can and not what we need to do and not what the research asks us to do. Okay, so the linguistic view of semantic change is quite different than what I described to you so far. Okay, lexical meaning can change over time. It is being, the cornerstone of historical linguistics, and at least since Isaac in the modern age, the last 200 years almost. But of course, linguists never bothered about the fact that words change their meaning, but they already observed that there are different types of meaning change. For example, broadening or widening of meaning change. The word bird used to denote a young bird in the past, and now denote any kinds of birds. There is the opposite called narrowing. That meat used to denote any kind of food, and now it's only relevant to edible flesh. A different type of change is related to amelioration. The word knight, or its original form in Middle German or Old German, Knecht, was a servant boy, and when it migrates with the Anglo-Saxon to England, it later became known as a nobleman. We have the opposite in awful, and of course, a case of metaphorical extension, like the word broadcast, from spreading seeds to transmission electromagnetic waves over the ether, and so on and so forth. So this is how linguists, this is one way in which linguists view semantic change. They're not really interested in whether it changes or not, but how it changes. At the same time, what LLMs or NLP tools can provide is, at best, okay, a certain number, a scalar number that represents how much a word changed, okay, or even a binary score whether the word changed or not. And there is, and this is of course true for all models, whether they're static, contextual, topic models. I would argue the same. This is the same case for large language models, of course, but there is a gap, a severe gap between these two research disciplines, okay, and we try to bridge it, okay, because the report of change that is we currently have in machine learning is not detailed enough and is not useful. So we tried in the last couple of years to enrich models with linguistic information, mostly sentiment, augmenting sentiment-based model into models of meaning. So we have another dimension, at least, of how does the word change, okay? And if you stay tuned, coming up in ACL 2024 soon in Bangkok, we also try to model other types of semantic change, and I think it's a worthwhile read. But still, I think we're dodging the question. This is going to be my concluding. So after the summary slide, there are going to be a few more slides. So a summary of what I showed you so far, which is, I try to give the most, not 101, but introductory course on computational semantic change. So semantic change is ubiquitous across languages as far as we know, because again, most languages do not have historical records. Most languages, of course, are not even written. So we have a very limited sample. But from what of the languages that we do know, they all show semantic change. Semantic change dramatically reduced performance of large language models over time. This is the work I show you about the temporal gap. The robots are changing. And this is, of course, also true on domains. And it can incur significant cost because we now need to retrain our model, or at least to be aware that their performance is significantly lacking of the performance that were promised when they basically were trained and tested originally. Semantic change, but on the bright side, of course, semantic change opened the door to study of historical, sociological, and cultural phenomenon, as well as linguistic theories, as I showed you before, about part of speech classes and so on. But current models lack in several key aspects. They contain numerical statistical confound. One of them is frequency, but there are more, unfortunately. The outputs are not in line and sometimes even incompatible with how linguists view semantic change. And LLMs completely ignore the dynamic nature of language. And this is going to be my concluding remark, going back to the question, what is a good model? Okay, so we had the geocentric model and heliocentric model. And we believe today that heliocentric model enables this scientific advancements because by modeling something, this is the only way we can understand something. I hope you all know that the phrase all models are wrong, but some are useful. Now, the question that I would like to end here, and this is how we tie to understanding a large language model understanding, is whether or not the current way we model language suffices for our understanding. What do I mean by that? Are large language model good models if even they do not exhibit key linguistic phenomenon as such as language change? So we know a large language model trained on mask language prediction or next sentence, and sometimes they are being fine-tuned on a host of tasks, but can we trust a model to actually represent human-like understanding if this model do not exhibit key feature linguistic phenomenon, in this case, a language change. So our models of change are very, very static, okay? Currently, we study semantic change by analyzing static snapshots of language usage. So, from history of photography and film, we knew that if we snapshot how a horse gallops, we may have an understanding of how it moves, but this is still static, okay? And there is no model at the moment, as far as I know, as far as not even in the stages of development, that tries to incorporate the dynamic nature of language into that model. What do I mean by dynamic language of language? Language change is not, is a fundamental part of language, okay? We all start our life without knowing anything, so we acquired language. There is a phenomenon of generational transmission of language from our parents and community to us. There is no distinction, almost hardly any distinction between different speech communities in the corpora that are used to train large language models and in control of the individual input and output. So there is no modeling of what's happening in the agent or in the core of the model and how they incorporate new meanings or new grammaticalization rules and so on and so forth as they emerge, and how much they are surprised by them, okay, as we imagine we were. So basically, without this kind of dynamic nature of model, we cannot transition from still photography to basically how the first new, I would say, idea of how horse gallop as a combination of snapshots. So again, the question I mentioned before, so good language model, human-like, should exhibit key linguistic features as an emergent property or not an emergent property. The example I try to give you here, semantic change. And the benefit of that is that with good models that we can actually trust that process language in a similar way that human process language, we can then better address the challenges that are faced by language change for linguistics, for cultural analysis, and for AI. And with that, I will conclude, and thank you.
Thank you. And now we'll applaud and you won't hear it.
Very frustrating. But hey, I got all the compliments I got. I'm like a large language model. How large? Can you be more specific?
It's open to questions now, and I don't see any in the attendees yet or here. So I'm always hesitating to say anything because I don't want to take away the time from anybody else, but it looks like nobody's really challenging right now. So I have a few questions for you. Is there, you have measures of closeness by co-occurrence. Is there, however, anything like true synonymy?
Yeah. So in our works, in our group, in previous work, that first of all look at lexical replacements. Okay, so if you can find a word that could replace a certain lexeme in a sentence, then you can treat that as a sort of a language change. How far in meaning a word you can replace a word in a sentence, and still sentences could have the same meaning.
That sounds like an operational criterion.
Mm-hmm.
Yet, I think you'll agree, there may be some exceptions where they're literally using the same symbol. You'll agree that when you take two so-called synonyms that co-occur under the same circumstances, that you can nevertheless specify the difference in meaning between them. So they're not truly synonyms. They're just words that are so close in meaning that they can be used in the same places. But then the metric which you're using, which is co-occurrence, breaks down there because you have non-synonyms that have the same co-occurrence statistics.
I think
synonyms means they mean the same thing.
Yeah, okay. So yeah, I'm not sure I agree. I know this is like how we conceive synonyms. But there is, I think the opposite view, the view that I hold is that even synonyms do not mean exactly the same thing. Otherwise, they will be completely redundant
Yes.
and may not exist. So either they represent something in a different register, or more related to a certain domain or genre, or a bit older and became obsolete. But some will argue that spoken, at least spoken, or spoken in a sense like used language, do not have the redundancy in the sense of synonyms, because they do not represent the same, exact the same meaning. Um, but this is only one way for different operationalization of meaning.
Well,
We can.
look, it captures the main question that we're asking about LNMs, about do they mean anything? Do they understand anything? If synonyms don't mean the same thing, then the kind of metrics that are used in next prediction of next occurrence, etc., then they don't work really, or at least they're extremely approximate. What they can say is something about proximity, and that's all. Only about proximity, not about whether about meaning. Yeah, I mean, if you have a bunch of nonsense syllables, some of which are mentioned more often than others, that still doesn't. That just tells you that they co-occur more often. Do they mean anything? I'll put it in another way. You showed those pictures of those horses, first separate images and then the dynamic. The separate image of view is what you get from the word analysis. What might
Exactly.
become dynamic would be take the kinds of cross-time analyses that you use and label the words, not just with what other words how close they are to other words, but when they were first pronounced, or when they were pronounced, basically what the date of the text was in which they appeared.
Mm-hmm.
And then if across time, you showed in another slide that there were tendencies that you could pick up dynamically across time. That across time change in word co-occurrence frequency could be interpretable.
Okay, so
That's a comment. It's not a question.
okay, so yeah, so yeah, yeah, I would tend to agree. Um, so okay, so I'll try to say something about synonymity again. So it could be that synonym words would hardly appear in similar co-occurrence contexts because they represent different domains, because they represent different registers, especially if you try to go to biomedical text or legal text and so on and so forth. So they try to mean the same thing, but only on a very specific context. So I would say classical co-occurrence analysis will not find them synonyms because they will appear with different text altogether. Um, what happens if we train large language model on the majority of text that's available to us? We don't know exactly.
The prototypicality effect that you
Mhm.
found useful, and then it disappeared under certain conditions.
It disappeared, yes, when we took frequency into account as a confound, because we didn't want that frequent word with as a baseline model, we took only frequency as a confound factor, and we found that in a regression analysis, prototypically only slightly adds to frequency. If we do not count, if we do not take into account the free frequency before, it seems that the frequency has like a major effect. But if we take it into account in a simple regression, it seems that frequency can explain a lot of what other linguistically motivated factors or regressors uh, can explain. And I think there are a few questions in the chat.
Are there finally? Yes, that would be wonderful. Do you have the line there? Go straight to the chat. It's yours.
Yeah. So Zep asks if do we have measures of how much individual people change their language uses over time, over lifetime, with respect to their linguistic properties? How well will that compare to that? Okay, fantastic. Yes. Thank you, Zep. No, we do not have that as far as we know. Some people, maybe not in computer science, in psychology, cognition, education, may have this really fine-grained corpora. We're trying to collaborate with them, trying to figure out what they can add to our models. If you're interested, please be in touch. This is one of the things I think LLMs are lacking. Because when they're trained on massive corpora without these kind of distinctions. When we are brought up and we have we acquire language, we first encounter and experience language with a very small group of people, our parents, nannies, and so on, and later on with our people in the nursery, in high school, and so on and so forth. We gradually extend the types of linguistic utterances and sentences we're exposed to and being and the different types of communication needs we have. This is not the way how large language models are trained, as far as I know. That would be super interesting to address that. There is even, I would say, an urban legend that in the future, we will all have our personal agent of a large language model that will be at least fine-tuned on our own individual linguistic inputs through our chat history, emails, and so on and so forth. So maybe I would say 15, but that I'll be very optimistic. Maybe in 5 years' time, we'll already have large language models which represent or have a better representation of our of individuality in terms of linguistics pertaining to our own idiolects. And Penny asks, thank you for answering my question. Do you think that the increase of use of AI based on these languages model will affect how language changes? Yes. Of course, I guess it's like it's open for debate. I think it depends on how much we will resist the type of prompting, in the times of the type of input that we used in LLMs, and if we prefer our chat agents to understand us better, then it is most likely will have some sort of an effect. I think it would be worthwhile to compare it to what we know from linguistic research over the past 50 or 100 years of how endangered languages reacted to the cases of language contact when they came in contact with new languages and cultures and civilizations. How did it affect their own language change? Though again, I doubt it if there is enough documents like on the before and after. But I think it's a fascinating question. Thank you. Julia asks, does the calculated meaning change line up with the emergence of new senses or new related forms as well? Examples, world with pi or pi roots like pets had led to solid pen and something. Do you have thoughts of why some words seem to be more stable, at least phonologically and maybe semantically than others, like foot? They perhaps somehow more prototypical or fundamental concept. There are also the especially slow changing toponyms and toporic names. How can we leverage lexical statistics? Oh, good, lexical statistics. Great, plus LLMs, given their amazing access to vast amount of information to understand language or our cognition, our history. Fantastic, Julia. Great question. Find it very hard to answer without just mentioning what we know from historical linguistics in the past. Right? So I'm not sure I can add to that, but you probably are familiar with the Swedish list of words that I think there is the original Swedish list. I think 80 or 100 words in the extended version, which is 200 words or something like that. That Swedish used to basically measure how languages change over time and how languages that emerge from a common ancestor, proto language, can and expected that similar languages or language in a subfamily will be more similar. And this is actually what we see here. I think he calls it like core vocabulary. It was like mother and father and numbers 1 to 10 and bread and son and so on and so forth. And we actually see that it's kind of in line quite well with what we know about phylogenesis of languages. And also there was the idea of glottochronology, which I think you might refer to when you say lexical statistics. I'm not sure. Basically, is there in a similar way that there is the mutation rate in evolution that helps us to understand when a species diverged from its prototypical father, when certain words have diverged. And as far as I know, it failed completely in terms of in linguistics, because there are so many intervening factors, and also degree of language contact, and perhaps other factors like whether or not the language was started to be written or not, and so on. But I think it's fascinating. I'm happy to continue that. Like, oh, I see you're online. So if you would like to comment on my comment.
Everything, the glottochronology and Swedish list was exactly what I was thinking of.
Oh.
Yeah, I would just love to pick your brain more because it feels like such a rich area where we now have a tool that can take all these text across languages into account simultaneously. So it just feels like an area we have to do things with.
Okay, so I must say that like 10 years ago when I started my PhD and doing on lexical change, nobody thought it was a thing. It was impossible, and it would never work. I think now we show that it can work, and we have enough venues and people that are interested in hearing that. So maybe it's time to revisit these kind of old ideas and terminologies. It seems that we have some so this is what we're trying to do. Some of the things we're trying to do in Change is Key, and on also my personal research, try to understand whether or not we can even rebuild a tree of languages only based on the lexical level. So try to connect it with linguistic typology and so on. There is some work done in this field, but not huge amount of work. You probably know the group from Jena that is doing. Okay, I have to refresh my memory. Still, even whatever Stephen might have said, I'm not a good language model, and I can get back to you, or you can send me an email.
Okay, I will. Thank you so much.
Thank you.
Okay, 2 more comments.
Okay, so D asked, how do you calculate semantic change from time-sliced word embedding models? How do you align the spaces to make sure the vectors are comparable? So D, I could happily say that this is a solved case, and there is proven mathematical ways to align embedding spaces on the one hand side, and the other hand side, there are ways which you can use to actually bypass the problem altogether. It's called temporal referencing. I can refer to the paper we wrote in 2019. But also, again, if you use the procrastinator methods and you're interested in aligning spaces, this is also is easily done today if you have enough seed words. It also appears in, I think, I hope we mentioned it in the book chapter. We wrote about different methods of computational semantic change. And if it's not clear, again, I'll write me an email, and I'm happy to send you the references. Similarly, how to solve the problem of alignment in cross-domain corpus in order to measure change exam. Okay, so the same question apply here. One method might be superior over the other. The more close are the two domains, okay, I think you can leverage the alignment method a bit better, but again, I'm happy to provide references and key inputs. And last question, Vishnu. I recently noticed that writing plural returned wrong translation and singular words separately by as giving two translation. What is the lexical difference between the two? Vishnu, in which, if you're around, in which language did you try that?
Type it, Vishnu, I can't elevate you.
Excuse me?
Just type which language you had in mind, you were referring to.
Which language and preferably which words?
Okay. In the meanwhile, I want to apologize. I would not have asked you so many questions if I had seen that the Q&A was full. I was desperate.
Telugu and Hindi. No. They were good. Actually, they were the good question because I was not able to answer them. Provide an answer that can fully alleviate your concern. So Telugu and Hindi. So Vishnu, okay. Language model, I'm sorry to say, does not really work on Telugu and Hindi, and we tested this. Okay, this is like I mentioned briefly the democratizing AI project. Also can refer you to a recent paper we wrote about Hindi. They failed. Okay, and I'm sorry, and I hope nobody from. I actually hope the opposite. I hope people from the industry is here. Meta, Google. Okay. There are dedicated large language models or contextual models trained by Google, by Meta on Indian languages, which are really not low resource, okay? But there are less resources and less in the focus of NLP research. And they, big companies give us promise us that, okay, we created multilingual models, embedded and specifically for Indian languages and what have you. And admittedly, they can generate reasonable, high quality text. But when you just try to scratch the surface, the level of, let's say, even like semi-superficial understanding about polysemy, about different senses, they fail completely on any standard benchmark, really. So if you're interested to work on either Telugu or Hindi, please, again, contact me. We're doing that right now. Okay, we're working on a bunch of Indian languages, and we see that it doesn't work, and we also try to understand how we can improve that without massively investing in training a large language model on corpora on a scale that does not match English. But good questions, and I'm not surprised that even changing from singular to plural change completely or breaks the model completely.
Okay, thank you for that, the discussion and for your talk. And I would like to bid farewell with another round of silent applause, which you can't hear.